You unlock your phone with your face. A warehouse scanner reads parcel barcodes automatically. A self-driving car sees a stop sign and brakes. All of that is computer vision. And in this video, you're going to be tested on exactly how the AI-900 exam expects you to understand it. 10 questions, all from the computer vision domain, including a multi-part service selection question at the end that trips up even well-prepared candidates.
How many can you get right?
Let's find out. Welcome back to Skills on Cloud. If this is your first video, start with part 1 of this series. The link is in the description. Subscribe and hit the bell so every new part lands in your feed the moment it drops. Now, let's get into the questions. Here is what you need to know about this exam domain. Computer vision workloads on Azure carry 15 to 20% of the AI-900 paper. The key challenge is not understanding what computer vision is. It is knowing which Azure service to pick in a given scenario. There are 3 services you must be able to distinguish. First, Azure Computer Vision Service, which provides pre-built general-purpose capabilities with no training required. Second, Azure Custom Vision, which lets you train a model on your own labeled images. Third, Azure Face Service, which is dedicated to detecting, analyzing, and recognizing human faces. The exam will give you a scenario and 4 options with these services mixed and swapped. Today's questions will build the decision framework you need to answer those questions confidently. Let's start. Question 1 of 10. A developer uses an Azure service to analyze a photograph and automatically generate a written description of what is depicted in the image, such as a group of people sitting around a table. Which Azure Computer Vision capability is being used? Option A, Object Detection. Option B, Image Classification. Option C, Image Captioning. Option D, Optical Character Recognition. Take a moment to think. The correct answer is C, Image Captioning. Image captioning automatically generates a natural language description of the entire scene in an image. Object detection identifies and locates specific objects within an image using bounding boxes, but does not produce a sentence description. Image classification assigns a category label to the whole image without describing the scene in words. Optical character recognition, also called OCR, extracts printed or handwritten text from images. Key memory trigger, written sentence describing a whole scene equals image captioning. Question 2 of 10. A self-driving car system must identify the position and boundaries of every pedestrian, vehicle, and traffic sign visible in its camera feed at any given moment. Which computer vision task best describes this requirement? Option A, Image Classification. Option B, Semantic Segmentation. Option C, Image Captioning. Option D, Object Detection. Think carefully about the distinction. The correct answer is D, Object Detection. Object detection identifies what objects are present in an image and where they are located, returning a bounding box and label for each detected object. The self-driving scenario requires knowing both what the objects are and their precise positions. Image classification labels the whole image with a single category and does not locate individual objects. Semantic segmentation assigns a class to every individual pixel, which is even more granular than object detection and typically used in medical imaging or advanced autonomous systems. Image captioning generates a text description. Key trigger: what plus where for multiple objects equals object detection. Question 3 of 10. A manufacturing company wants to train a model that classifies circuit boards as either pass or fail based on photographs taken on the production line. No existing pre-built Azure service covers this specific use case. Which Azure service should they use? Option A, Azure Computer Vision Service. Option B, Azure Video Indexer. Option C, Azure Custom Vision. Option D, Azure Form Recognizer. Consider the scenario carefully. The correct answer is C, Azure Custom Vision. Azure Custom Vision is specifically designed to let you train your own image classification or object detection model using your own labeled images. The manufacturing company needs a custom-trained classifier for a domain-specific task that no pre-built service covers. Azure Computer Vision Service provides general-purpose pre-built capabilities like tagging, captioning, and OCR, but cannot be trained on custom categories. Azure Video Indexer analyzes video content for speech, topics, and faces. Azure Form Recognizer extracts data from structured documents. Key trigger: custom categories trained on your own images equals Azure Custom Vision. Question 4 of 10. A company wants to build a system that verifies whether the person presenting their face to a camera matches the photo on their employee ID badge. Which Azure service is designed for this use case? Option A, Azure Custom Vision. Option B, Azure Computer Vision Service. Option C, Azure Content Moderator. Option D, Azure Face Service. Take your time. The correct answer is D, Azure Face Service. The Azure Face Service provides capabilities specifically for detecting, analyzing, and recognizing human faces. Face verification, which checks whether two faces belong to the same person, is a core capability of the Face Service. Azure Custom Vision can detect objects, but is not optimized for facial identity. Azure Computer Vision can detect that faces exist in an image, but does not perform identity verification. Azure Content Moderator screens content for inappropriate material such as adult or violent imagery. Key trigger: face-to-face identity verification equals Azure Face Service. Question 5 of 10. A logistics company wants to automatically read the tracking numbers printed on parcel labels from photos taken by warehouse scanners. Which Azure Computer Vision capability should they use? Option A, image classification. Option B, optical character recognition. Option C, object detection. Option D, image captioning. Think about what information needs to be extracted. The correct answer is B, optical character recognition, also known as OCR. Optical character recognition is the process of detecting and extracting printed or handwritten text from images. Reading tracking numbers from parcel label photos is a direct application of OCR. Image classification assigns a category to the whole image, not text extraction. Object detection locates objects with bounding boxes. Image captioning generates a descriptive sentence. Azure Computer Vision and Azure AI Vision both include built-in OCR capabilities via the Read API. Key trigger: extracting printed or handwritten text from images equals optical character recognition. Pause right there. What is your score out of 5 so far? Drop it in the comments right now. And a heads up, the second half includes the multi-service selection question that catches out the most candidates in this domain. If you are shaky on the difference between Azure Computer Vision, Custom Vision, and Face Service, the next 5 questions will sharpen that up for you. Let's keep going. Question 6 of 10. A media company wants to automatically generate transcripts, detect which celebrities appear on screen, identify topics discussed, and extract key moments from thousands of archived news video files. Which Azure service is best suited for this workload? Option A, Azure Custom Vision. Option B, Azure Media Services. Option C, Azure Video Indexer. Option D, Azure Computer Vision Service. Consider what each service specializes in. The correct answer is C, Azure Video Indexer. Azure Video Indexer extracts rich insights from video files, including automatic speech transcription, face identification, named entity recognition, topic detection, and scene detection. It is purpose-built for the kind of multi-modal video analysis described. Azure Custom Vision handles custom image classification and object detection, but not full video intelligence. Azure Media Services handles video encoding, streaming, and delivery, not content intelligence. Azure Computer Vision analyzes static images, not video files at scale. Key trigger: transcript plus faces plus topics from video equals Azure Video Indexer. Question 7 of 10. An organization deploys a facial recognition system for building access control but later discovers the system has significantly higher error rates for individuals with darker skin tones. Which responsible artificial intelligence principle is most clearly being violated? Option A, reliability and safety. Option B, fairness. Option C, transparency. Option D, inclusiveness. Think about which principle this most directly maps to. The correct answer is B, fairness. Fairness requires that artificial intelligence systems treat all individuals equitably and do not produce biased outcomes based on personal characteristics such as race or skin tone. A facial recognition system that performs significantly worse for darker skin tones is producing discriminatory outcomes and violating the fairness principle. Reliability and safety relates to consistent, safe performance overall, not differential performance across groups. Transparency relates to explainability of decisions. Inclusiveness relates to ensuring all people can access and benefit from artificial intelligence. Key trigger: differential error rates across demographic groups equals fairness violation. Question 8 of 10. A developer needs to quickly add the ability to describe images, detect common objects such as cars and trees, and read text from photographs using a pre-built service with no model training required. Which Azure service should they use? Option A, Azure Custom Vision. Option B, Azure Face Service. Option C, Azure Computer Vision Service. Option D, Azure Form Recognizer. Think carefully about the no training required condition. The correct answer is C, Azure Computer Vision Service. Azure Computer Vision, now part of Azure AI Vision, provides a rich set of pre-built, ready-to-use capabilities including image captioning, tagging, object detection of common categories, and optical character recognition, all without any custom model training. Azure Custom Vision requires you to supply and label your own training images. Azure Face Service is specialized for facial analysis only. Azure Form Recognizer is for extracting structured data from documents and forms. Key trigger: pre-built vision capabilities with no training needed equals Azure Computer Vision Service. Question 9 of 10. A plant identification app analyzes a photo and returns a single label, rose, indicating the type of plant in the image. A second app analyzes the same photo and returns multiple labels, each with a bounding box, showing exactly where each flower, leaf, and thorn is located. Which statement correctly identifies both tasks? Option A, both are object detection tasks. Option B, both are image classification tasks. Option C, the first is image classification and the second is object detection. Option D, the first is object detection and the second is image classification.
Take your time.
The correct answer is C. The first is image classification and the second is object detection. Image classification assigns a single category label to the entire image. Object detection returns multiple labels and the bounding box coordinates of each detected instance within the image. These are two distinct computer vision tasks. Key memory hook: one label for the whole image equals classification. Multiple labels plus locations equals object detection. Question 10 of 10, and as always this is the trickiest question in the set, so read every word carefully. A retail company has 3 requirements. First, they want to automatically tag uploaded product images with relevant keywords such as red, leather, and handbag using a pre-built service. Second, they want to verify that delivery drivers match the photo on their employee ID before accessing the warehouse. Third, they want to detect a specific custom product defect that no pre-built service can recognize using only 500 training images they have already labeled. Which combination of Azure services correctly addresses all 3 requirements? Option A, Azure Computer Vision Service for all 3 requirements. Option B, Azure Computer Vision Service for the first requirement, Azure Face Service for the second, and Azure Custom Vision for the third. Option C, Azure Custom Vision for the first requirement, Azure Face Service for the second, and Azure Computer Vision Service for the third. Option D, Azure Computer Vision Service for the first requirement, Azure Custom Vision for the second, and Azure Face Service for the third. Now here is where many candidates go wrong. They either assume one service can do everything, or they swap the face service and custom vision roles. Let's work through each requirement. Requirement 1, tagging images with common descriptive keywords using a pre-built service. That is a standard capability of Azure Computer Vision Service, no training needed. Requirement 2, verifying a person's face matches an employee ID photo. That is face verification, which is the dedicated job of Azure Face Service. Requirement 3, detecting a specific custom defect with labeled training images. That is exactly what Azure Custom Vision is designed for. You supply the labeled images, and it trains a custom model. The correct answer is therefore B. The trap in this question is option A, which seems convenient, and option C and D, which swap the roles of the services. Always match the service to its core specialization, pre-built general vision, custom trained vision, or facial identity. How did you go? That last question is one of the most common traps in the computer vision domain, so if you got it right, genuinely well done. Post your final score out of 10 in the comments. I read every single one. Now here is what is coming in part 4. We are moving into natural language processing on Azure. That means understanding the difference between the Azure Language Service, the Azure Translator, and the Azure Speech Service, and knowing which one to choose when the exam gives you a text-based scenario. If you have ever mixed up sentiment analysis with entity recognition, or wondered when to use speech-to-text versus translation, Part 4 will give you absolute clarity. Subscribe now. The countdown is on your screen. I will see you in Part 4.